Alright, so today we have the most used networking model in our days is the TCP IP model. We have task number 4 in the introductory networking, which is from the complete beginner path. The TCP IP model is in many ways very similar to the OSI model. It's a few years older and serves as the basic for real-world networking. The TCP IP model comes from Transmission Control Protocol, TCP, a transport protocol basically, and the IP, which comes from the TCP IP model, is in many ways very similar to the OSI model. It's a few years older and serves as the basis for real-world networking. The TCP IP model consists of 4 layers: application, transport, internet, and network interface. Between them, these cover the same range of functions as the 7th layer of the OSI model. These 4 layers from the TCP layer, actually you can see them here, are the same but a bit, let's say, concatenated or combined. As you can see, the OSI 7 layers with the 4 layers of TCP IP. Note, some recent sources split the TCP IP model into 5 layers, breaking the network layer into data link and physical layer, which you can see here, network layer, which you can see it here, network interface on 4 layers of the TCP is broken down into the 2 that OSI model has for some models on the internet. This is accepted and well known, however it is not officially defined, unlike the original 4 layer, which are defined in RFC 1122. As you can see it here from IETF organization, Internet Engineering Task Force, which is the organization developing standards for the internet, you can see the standard mentioned in TryHackMe right over here. You can read about it and learn more about this protocol. This RFC covers the communications protocol layers, right? Link layer, IP layer, and transport layer. It's up to you which version you use. Both are generally considered valid. You would be justified if asking why we bother with the OSI model if it's not actually used for anything in real world. The answer of that question is quite simple, that the OSI model, due to being less condensed and more rigid than the TCP IP model, tends to be easier for learning and initial theory of networking. The 2 models match up something like this. As you can see, the application presentation session from the OSI are condensed into only the application layer. Transport is the same on both models, and network with internet from the TCP IP, and here condensed data link with physical with network interface on TCP. The process of encapsulation and de-encapsulation work in exactly the same way with the TCP IP model as they do with the OSI model. At each layer, the TCP IP model, a header is added during encapsulation and removed during decapsulation. Now let's get down to the practical side of things. A layered model is great as a visual aid. It shows us the general process of how data can be encapsulated and sent across a network, but how does it actually happen? When we talk about TCP IP, it's all well and good to think about a table with 4 layers in it, but we're actually talking about a suite of protocols, sets of rules that define how an action is to be carried out. Basically the definition of a protocol. Set of rules that define how an action is being carried out. TCP IP takes its name from the 2 most important of these, the Transmission Control Protocol, which we touched upon earlier in the OSI model, that controls the flow of data between 2 endpoints, and the IP protocol. You can see them marked with bold effect, which controls how packets are addressed and sent. There are many more protocols that make up the TCP IP suite. We will cover some of these in later tasks. For now, though, let's talk about TCP. As mentioned earlier, TCP is a connection-based protocol. In other words, before you send any data via TCP, you must first form a stable connection between the 2 computers. The process of forming this connection is called a 3-way handshake. When you attempt to make a connection, your computer will send a special request to the remote server indicating that it wants to initialize a connection. This request contains something called a SYN, short for synchronize, a SYN bit, which essentially makes first contact in starting the connection process. The server will then respond with a packet containing the SYN bit, as well as another acknowledgement bit called ACK. Finally, your computer will send a packet that contains the ACK bit by itself, confirming that the connection has been set up successfully. With the three-way handshake successfully completed, data can be reliably transmitted between the two computers. Any data that is lost or corrupted on transmission is resent, thus leading to a connection which appears to be lossless. We have here a request between a client and a server, and here we can see the communication from the client to the server with the initial synchronization, and then from the server the synchronization with the acknowledgement, and then we send back the acknowledgement, thus creating the connection. We have here SYN ACTRA, a way to remember the SYN ACK, the three-way handshake. We're not going to go into exactly how this works on a step-to-step level, not in this room at any rate. It is sufficient to know that the three-way handshake must be carried out before a connection can be established using the TCP. History. It's important to understand exactly why the TCP/IP and OSI models were originally created. To begin with, there were no standardization. Different manufacturers followed their own methodologies, and consequently systems made by different manufacturers were completely incompatible when it came to networking. The TCP/IP model was introduced by the American DoD in 1982, Department of Defense, to provide a standard, something for all of the different manufacturers to follow. This sorted out the inconsistencies problems. Later, the OSI model was also introduced by the International Organization for Standardization, ISO. However, it's mainly used as a more comprehensive guide for learning, as the TCP/IP model is still the standard upon which modern networking is based. Which model was introduced first, the OSI or the TCP/IP model? TCP/IP model. Which layer of the TCP/IP model covers the functionality of the transport layer of the OSI model? Is the transport. The transport layer. Which layer? Transport layer. Which layer of the TCP/IP model covers the functionality of the session layer of the OSI model? Application. The network interface layer of the TCP/IP model covers the functionality of two layers in the OSI model. These layers are data link and physical link. Which layer of the TCP/IP model handles the functionality of the OSI network layer? Internet. Which kind of protocol is TCP? Here we can see connection-based protocol. What is a SYN short for? It comes from synchronize. What is the second step of the three-way handshake? Is right over here. It's a SYN ACK, synchronization acknowledgement. What is the short name for the acknowledgement segment in the three-way handshake? We just used it. All right, cool.